Hi everyone. Today I will teach you data structure with Python. So first of all, I will teach you with the help of PPT. Then with the help of pen tab, I will teach you by making the diagrams and solve one coding questions with the help of Python. Okay, and that question is related to stack. So data structure with Python, data structure. Okay, so I can correct it. So this is data structures. Then we can write here is stack with Python. Okay, so this is now what is data structure. So first of all, what is data structure? We are moving towards our topic, but before moving, what is data structure here? Okay, so data structure are the programmatical way of storing data so that data can be used efficiently. A list of algorithm. So what is algorithm? So what is data structure? Assume if we are in home and if we put the biscuits, instead of putting the biscuits in the packet, I want to put the biscuits in the container. So how we are going to put? So what we need to put the biscuits? We need container. Maybe it's a plastic container, maybe it's a steel container, maybe it's a glass container, maybe it's a some other type of container of any material, but we need one of the container in which we can store the biscuits in a ordered way. So what is algorithm here? Algorithm is the way we are storing the biscuits. Okay, so we know that we can put the complete packet in the container in any of the way. Okay, so maybe in random way, or maybe I want to put the biscuits in a ordered way. Okay, one after the other we can put. So we have the two ways. So algorithm gives us the numbers of step by which we can efficiently store our data in the data structure. So what is data structure? Data structure is a container. And what is algorithm? Algorithm is the way or technique I know to store the biscuits in the container. And here what is here? Data. So data is a biscuit, container is the data structure, and algorithm is the technique I know to store the biscuits in the container. So there are two type of data structure. First is the integer float character. So this is always present in any of the programming language. Maybe it's a C++, Java, Python, Swift, any language. These are the basic data structure. So what are the non-primitive? And this is also present in all the languages. So maybe it's an array, it's a list, it's a stack, it's a queue, it's etc. Okay, so primitive data structure are the smallest unit. Let me first tell. They cannot be break into smaller parts. Okay, so what is, let me, yeah, so primitive data structure are the smallest unit, integer, float, character. We cannot break it. But what is non-primitive? Non-primitive is the complex, non-primitive or the complex structure. Assume uh, we have we have a table. Inside this there are many drawer. Okay, and we want to put the many things inside each drawer. So it's a complex. Okay, because we need to put some things in a drawer and it will be filled. Then we need to open the second drawer and we need to again fill or again put the things whichever we wanted to fill it or we wanted to store. So that is a complex because we can store more than one items. But if we have just a small glass, a very small glass, chilling glass, in this we can only put a single thing. So you can assume that integer primitive cannot be break, but non-primitive can be breaked. Okay, so like an array, we can insert the several elements inside the array. So I hope this is clear, like what is data structure and how many types. So here we will learn what is stack. Okay, so in general world, in English, if we search on English dictionary and we write what is stack, so it will give us a pile of stack, typically one that is neatly arranged. And in computer language, what is stack? Stack is a data structure that allows insertion and deletion operation in LIFO. Okay, so what this is a stack. Assume this is stack and we are putting the book here. I have shown you the example. So this is the stack. So we are putting one book after another. So we are putting one book, inside this there are some other book. So we are putting continuously one after the other. So this is a stack because we are putting elements one after the other. And if we want to remove the element, then we need to remove the from the top. If we cannot remove from the bottom. If we remove from the bottom, then it will be disturbed. The piles of book will be disturbed. The arrangement will be disturbed. So we need to put one element from the top. So the element which we are inserting last, we are popping that element, we are removing that element from the stack first. That's why here it is written last in first out, or we can say it's a first in last out, because the element here you need to remember two things: last in first out, first in last out. So what that mean? Last in first out. So last element which we are putting here, that will be removed first, and first in last out, first in. So first element, first book we have pushed here, and that will be out last, because after that there are many books are there, so we need to remove that. Then at the last this book will going to be removed. So I hope this is clear from 2 points, and I will tell you and I will show you by my with the help of pen and tab. I will write the diagram and I will tell you what that means. Is if you haven't understood till now, not a problem, I will teach you in the next slide. A stack is an orderly list of elements. Example: stack storing the numbers of numbers, or stack of string. It is essentially, so I have told to you, when a stack is full, so assume that if we have a container and we want to put the biscuits, and if biscuit is full, then we will call it's a overflow state. And whenever container is empty, so previously when we take the container from my mom or from anyone else, then this is empty, so we are saying that underflow. Underflow means it is underflow, there are nothing inside the biscuit which is flowing out. So this is underflow. We can put the more numbers of biscuit, we can put the anything inside the container. So that's the called as underflow. But when we put the things inside the container and the container is completely full, and we are trying to fill the container and we are filling the more items in the container, then we will show it's a overflow state. You cannot fill more items because the container is filled. That's why, as you can see, this is a stack. So when we put a biscuit here, then put the biscuit here, then put the biscuit here, put it there. So until unless this is a top biscuit, okay, until unless you will not pop, you will not remove the biscuit from the top, you cannot get the biscuit after that. Okay, you cannot get the biscuit last one, until unless you will not remove all the biscuits with which are at the top from the last one. Okay, so we are pushing the element from the top and we are popping the element from the top. So inserting means pushing and removing means popping. I hope this is clear. Now our actual point is came here, how to implement stack using Python. So in Python we have list with the help of, so let me move this one. So there are various ways from which a stack can be implemented. Stack in Python can be implemented using the following ways: list, collection.tq, tq.lifo. So here we will only learn how to implement the stack using the list. So we are going to use these numbers of function for implementing our stack. So what is length of stack? So if we want to check that whether my container, assume that if my mom gives me the container, how will I get to know that whether my container is filled or not? But just by seeing, I can get to know that there is nothing inside this and container is empty. But if we are talking in computer language, in computer manner, so how we can say that our stack is empty? We will just check the length. If our length is 0, then we can say that stack is empty. And what is time complexity? Time complexity is big O of 1. So if we want to, if I want that how many biscuits, I mean, assume my mom given to me a container and inside this there are 4 biscuits. So how will I get to know that there are 4 biscuits? By counting the number of biscuits inside the container. So actually we are getting the size of the container, we are getting the numbers of biscuits inside the container. But if we talk in term of computer language, and how we will get to know? With the help of length of stack, it will give us the size of the stack, and a time complexity is big O of 1. And if I want to remove the top element from the stack, or we can say if I want to remove the top biscuit from the container, then how we will get that? By putting inside the hand in by putting the hand inside the container and taking it out the biscuit from the container, there. So that in this way we can get the biscuit from the top. But with, if we are talking in a computer language, how we will get the element from the stack? So we will write here stack minus 1. So that minus 1 refers to the last element, that, or we can say the top element of the stack. What is happened if I want to put more biscuits inside the container, then we will put one by one inside the one by one biscuit inside the container. In this manner we can put the biscuits. But and how we can remove? We can remove with the help of by just putting the hand inside the container and popping the biscuit from the container. So in this manner we can insert the biscuit, we can remove the biscuit. But if we talk in terms of stack, how we can get the biscuit, how we can insert the element or insert the data or remove the data with the help of append and pop. I hope this is clear. Okay, so first of all, let's take a overview of stack with the help of by making the diagram. So here stack. Okay, so assume this is a container and we are storing the biscuit here. Okay, so this is biscuit. Then after that we have biscuit, then we have a biscuit, then we have a biscuit, then we have a biscuit. So what I told to you, LIFO, last in first out, or first in last out. Okay, so this I told to you, and now verify it. Okay, so last in first out. So this is first one, this is the second one, this is third one, this is fourth one, this is fifth one. So this is our biscuits. So here data is biscuits. So the last element, so the last biscuit is one, last in first out. So the last element, the last biscuit I put, that is 5. And if I want to remove the one biscuit, or this you can say, assume the name of the biscuit is 1. If I remove the one biscuit, one biscuit from the container, then I need to remove these biscuits from the container. So last in biscuit is fifth one, and we need to first out, means the last biscuit which we have inserted here, we need to remove the first one. So that is correct, because we are popping the last inserted biscuits from that container. So this is container. Now first in last out, first in last out. So this is the first biscuit, this is the first biscuit. And if I want to remove the element, if I take the biscuit from the container, then first I will remove this biscuit, this biscuit, this biscuit, this biscuit. Then I can only reach to one. So it's saying first input, last first in last out. So first biscuit which have been inserted in the container, that will be removed last. So this is also correct. So this is our stack. I hope this is stack. And if you are taking the book 1, book 2, book 3, book 4, okay, so this is our stack. So until unless you will not remove these books from the stack, you cannot remove b1. Okay, so the first element, the last element that is inserted first, that will be out first, and the first element that is inserted first and will be removed last. I hope this is clear. So here with the help of list, so here we are going to use the list, okay, with the for implementing the stack. So we are using the function here, first for the empty, for getting whether my stack is empty, then getting the last element from the stack, last element of the stack. Actually all functions are not necessary for implementing the stack, only two functions are necessary, but in some question we need all of the function. Okay, so third is length of stack. Okay, fourth is the pop, or you can say append, for inserting, and the last element is a pop for removing. So this is the some function which we need for implementing the list, for implementing the stack using list. I hope this is clear. So assume, so here we will solve one of the question here. So the question is here a b. So let's first implement the stack here. Okay, so we will implement the stack here. So let's implement stack. So how we will implement stack? Assume I have the data. So what is data? Data is here. I have a 1 comma 2 comma 3 4 5 6. So first I want to insert 1, I want to insert 2, then 3, then 4, then 5, then 6 in stack. Okay, in stack. So how we will implement it? How we will implement it? So we are doing here using the Python. So we are using the Python language. So what Python language says, for index I in data, or you can say, so here I am taking the, I'm getting the element. So for element in data, so here first I will take the stack here. So firstly my stack is empty. Then what I will say, I will say stack dot append element. Okay, now data I have the data 1 comma 2 comma 3 comma 4 comma 5 comma 6. So our stack is empty. So when our element is 1, so our stack will be 1. When our element is 2, our stack will be 2. When our element is 3, our stack is 1 comma 2 comma 3. So similarly, when we reach as 6, so our stack will become 1 2 3 4 5 6. So now if we want to pop the element, so what stack says, so this has been stored in this manner: 1 2 3 4 5 6. Now if I want to pop the element from the top, so what I will do, I will again run a loop for element in data, or you can run a range here for index, and this will, so what I will say, for index in range length of stack. Okay, so this will go to the length. So what is length here? So what is this one? This one is the length of the stack, and our stack has 6 elements, so this will be 6. So first 0 index will be 0, and we will write here stack dot pop, and if we print it, then it will give me the element. Now when my index is 0, so stack dot pop, so stack dot pop, what it will give, it will give the last element. So last element is 6, so this will be 6. Whenever index is 1, whenever index is 2, whenever index is 3, whenever index is 5 4, then 5, then 6. So which element is going to be popped? So 6. Whenever is 1, so right now 6 has been popped. Now the last element is 5, because pop is always pointing to the top of it, so this is will be 5. Now 5 have been also pushed. Now whenever index is 3, now 4 element will be popped. Whenever index is 4, 3 element will be popped. Whenever index is 5, 2 element will be popped. Okay, so this is for 0, this is for 1, this is for 2, this is for 3, this is for 4. Now for 5, when I reach the index as 5, then I need to pop the 1. Okay, and it will not go 6, because the range goes from 0 to 6 hai, so it will include 0 1 2 till 5, but it will exclude the 6. So that's why it is our index is going from 0 to 5. Okay, so I hope that you are clear with the Python language, that how the length works, because I am not going to tell you because we are here to solve the stack, to implement the stack using Python. So I hope that you are clear with the Python language. So for implementing the stack, we need only 2 lines. So if we have a data, then these 3 lines and these 2 lines. Okay, so these 2 lines we need only, and these are just the explanation part for you. So don't think that why I have messed up the thing, or why I have written, do I need to write this one? No, you need to write only these 2 lines, these 3 lines, then these 2 lines, and your stack is empty. So what stack says, the last element which you have, the last in first out, last in first out. So last element you have inserted 6, and as you can see that have been popped first, and what the other says first in last out. So first element you have pushed 1, and that will be out last, as you can see. So this will be last in first out, and this will be first in last out. I hope this is clear. So if I will let's implement with the help of any compiler. Okay, so I am implementing the whatever we have whatever we have wrote here. So I'm implementing the same thing with the help of compiler. So assume we have a data. Okay, that I have a 1 comma 3 comma, so we have a 5 comma 6. Now I need to implement the stack. So implement the stack here. Okay, so let's take the stack. So we have a stack. Now for element in so let's take as a data list. So data list. So what I need to stack dot append, what I need to append element. Okay, now I've been appended. Now I need to implement the stack. So for index is range length of stack. So I will write here last in first out, or first in last out. So stack dot pop. So let's try to run. Okay, so in Python Python is a, okay, so as you can see, 1 2 3 4 element in the stack for I range, so why it is not okay. So as you can see, so first I will show you what is my stack here. Print stack. Okay, so let's run it. Stack. Okay, so this is our stack. So what is the stack? Stack is 1 2 3 4. As you can see, the last inserted element is 6, so that will be popped first. So 6 should be popped first. As you can see, the 6 have been popped first. Okay, and the 1 element have been inserted first, so that will be out first. So last in first out. As you can see, the first element, the 1 is popped last, and 6 which have been inserted last, that have been popped first. I hope this is clear how we can perform the stack with the help of Python. So I hope this is clear, and here I am taking this one to my next slide, so let's take this one. Let's implement the Python. So I am writing here stack with Python code. So I am writing here fast, because I hope that whatever I have teach you, that is completely clear to you. So that is the way we can perform the stack with the help of Python. So now this is Python. Now we will print it. Now we will this one. So this is our stack. Now our stack. Okay, Now we need to implement the stack. So I've taken this one. Now we have a data list. So we have a data list. So this is our data list. We need to implement the stack here. So I'm writing here at the top. Okay, so let it be. So stack. So this is one thing. Then okay, I hope this is clear to you. So let's the color. I hope you are clear how we can implement with stack with the help of Python, and what is data structure, that is also clear to you. So that is from my side. Thank you.